Hello. Now we are going to start a discussion on cloud service evolution analytics. In this cloud service evolution analytics, we will see theory of service evolution analytics, and that was being done with change mining and evolution mining over the distributed systems. It was being published on the work is being published on IEEE Transactional Engineering Management. Then the theory starts like this, that first of all we have to understand where this distributed computing lies. So distributed computing contains grid computing, cloud computing, utility computing, service oriented computing. What happened in grid computing, it's mother of all type of these new generations of computing. Like nowadays we start calling it cloud computing, that enables on demand shared computing resources. Before to the cloud computing, there was something utility computing, which says on demand, pay as you go model for billing purpose. And cloud computing also contains service oriented computing, that says sharing of remote web service. So all these things nowadays, they start everybody starts saying it as cloud computing, and cloud computing has been become a larger uh, product. Then the evolving distributed systems. So what does this say is that the evolving softwares are there. There has to be stored over some repository, and how these repositories are there. So in these repositories, there are some systems which are belonging to distributed systems, and they are changing with time. So like for example, Hadoop SDFS, Eucalyptus Core, there are other middlewares like Storm, etc., are the kind of distributed system which are evolving in nature. Then there's changeability and evolvability. So what does this is that changeability you can study with the help of change mining, evolvability you can study with the help of evolution mining. Thereafter, uh, what is the purpose of this? To uncover changes and evolution happened over time. Then what you want to study, the first of all we define like version series. What is version series of an evolving distributed system? It could be like v1, v2 up to vn, version n, for the different time snapshots, like v1 at t1 time point, v2 at time t2, vn at time tn. Then the change mining of the two web service could be studied with the help of service change classification. How we can do this? There are two steps to do this summarization. So there's old version and there's new version of input of a web service. What these version contains? These version contains WSDL files, web service codes. So so that we can do comparison based upon that. So the change mining could be taken place for the two versions, and for with the help of that we can study that evolving distributed system. And there's change mining al- algorithm for web service which has been introduced. So thereafter there are two algorithms are being invoked in this change mining of web service. First one is service change classifier, second one is WSDL slicing. So what is the flow chart of this? So you take two versions, and two versions both have WSDL and WS code for the new and old version. And then you apply algorithm one for the service change classifier and found out what are the operations, uh, whether it's deleted, modified, or inserted. Then you have up you have to process each of the operations such that with the new WSDL file, you just select only the subset WSDL to create a WSDL slice in algorithm 2. So only subset operations are being selected to create a new kind of WSDL, that is WSDL slice. Then uh, what are the types of changes and labels that we said over here? So what are the labels that we were discussing, operation labels? So this could be like insertion at WSDL level, that insertion of some operation in WSDL level or schema change, data types are being changed for input output. Thereafter, it can be captured in the difference WSDL. Then you have insertion WSD. Insertion could be done at web service code level. So insertion of the code, new operations are being inserted and new code lines are being inserted that could be captured in unit WSDL. Then deletion could be possible at WSDL level. So it means that some operations are being deleted and dysfunctional for the client. And WSDL code means deletion of the operations are dysfunctional at the code level. So these changes are happens such that this deletion does not affect uh, the change classification means or the testing part or the change mining evolution part. So these changes could be ignored, and in these changes usually the test cases failure happens. So there's two changes that are important, insertion and modification. In this modification, WSDL and web service codes are being changed to modification at the input output XSDs schema level data type, and WSDL code level where the modification of line happens without affecting some WSDL. So these are being captured in difference WSDL and unit WSDL. Thereafter, what happens? You have six part of web service descriptive language. What are these part? Definitions from the starting point. XML versions are there, name of services are there, XMLNS are there, target namespace are there, XSD data types are there, where input output of the two data type are being mentioned, that there could be complex data type or simple data type, where you can have changes happening to elements in the schema, changes happening to the names of the schema, data type changes happening. So there's so you can have a nested attributes or parameter, nested input output parameters you can have. Thereafter, you have message as the part of WSDL, where you have some operations that are having some elements and they are parts of message, and these are used for communication purpose. And there's a port type, means there's a link, you can say, which says that this is the link and this is the operation name, and this is where you have to call out with this message input and output will be used. Then binding is there. So binding is that how the soap name or how the binding names, means soap bindings could be done. Soap body means input output, means request and response are there. So how the soap bodies are there. Then service changes. So the changes at the service level is like you have service name, service binding address, some URL is there, and that soap address location. So all these things are being mentioned in service change. So this is an example where the service one is being modified to the service two, and this have operation one, operation 1.3, which actually the operations in the first version. Then there's a hypothetical example here that it's calling method 1.1, and it is also calling operation 2.1 in another web service, means remote web service calling is happening over there. Then you have the operation 1.2 for the same web service. What does this means? There's red color denotes that there's a significant change happened in a web service. So that significant change is being denoted with the help of red color. And there's blue color says that there's a modification had happened, that has been denoted with blue color. And there's insertion of new operation 1.2 happened in the second version, that this has been denoted with the green color. So there's green, red, and blue color to denote how the changes has been done while the upgradation from service 1 to service 2. Then this is the algorithm one for the service change classifier. How service change classifier works. So it's from here. So service change mining of web service calls service change classifier to find out what is the algorithm one is being called out, what are the operations with the uh, different kind of labels like insertion, deletion. Then WSDL slicing is being called out. So the this service change classifier says that semantic differencing of code differencing is being taken out for the web service code, old and new version. Then WSDL semantic differencing is being taken out from the WSDL code, old and new version. Then initialization of array takes place, where the op name is being op name is being operation name is being labeled with insertion, deletion, or modification, such that uh, what are the and initialized with the unchanged label means initially was being initialized that all the operations are not being changed unchanged, then it retrieves operation changes for the WSDL code and WSDL changes with some change label. Thereafter what happens for each operation name which has been changed means this operation name which has been changed, so in the WSDL changed, so this if it is inserted, this operation name is being inserted, then that should be put out as insertion. Then if the operation name has been deleted, then the deletion would be put out in the that operation name. If the operation name is changed, then if it is being modified, then you put the uh, modified modify that operation change label. Then operation name changes happens at WSDL code changes, then operation name changes has happened at insertion level, and at the code level changes, so the code level changes happen, then you have inserted on the operation name, uh, you have deletion at the operation name, and you have modification at the operation name. You can do uh, like this. So at the end, you'll get operation labels with operation name, which is having some changes at different labels. So labels are like insertion, deletion, and modification. Insertion, deletion, and modification either at WSDL code level changes or at the WS web service code level changes or at the WSDL level changes. So these are being created. Op label are being created over here. This label has been created. This op level will go to WSDL slicing. WSDL slicing takes new WSDL as well as subset operations. So over here, it will take algorithm, and then what happens? It will start creating different parts of a WSDL, that start definition, XSD, message, port, binding, services, and end definition. So it starts selecting these parts over here. Slice is being start creating. So the subset operation is being taken out from this uh, operation of new WSL. So there is operations in the new WSL. You just uh, find out what are the subset operations that belongs in this, so that you can create a operation that is required for construction of WSDL slice. So subset operation are being finded out uh, in this WSDL. So this subset operations are being find out inside this WSDL new. So this is a part of slicing. So this is slice which are being created. So first part, second part, third part, fourth part. So this is what we studied over here. First, second, third, fourth. So this is how it's like this, and then the combination of all these parts are happening over here. So it is just a text in concatenation, you can say, and in the end you'll get WSDL slice. Then, uh, what are then till now we had seen change mining over here. This change mining we had studied. Now, what we are going to study, we are going to study uh, the evolution mining. How we are going to study evolution mining? So, evolution mining basically says that there is some matrix, if you could define, and if you could define a matrix and over the time period, so that you can study that matrix over the time period, so that you find out some trend or something information like that. So there are four metrics that are being introduced. What are these four metrics that are being introduced? And we are going to see that based upon the four different mm, five different quantitative attributes available in the web service. What are these? Number of operations, number of WSDL lines, number of parameters in the WSDL, number of messages in the WSDL, and what's the number of code lines available. So based upon these five important attributes, we are going to find out what is the evolution analytics that so this line per operations in the WSL. So this is a matrix in every version. So number of source lines are there in the WSDL version 1, and there's number of operations in the version VI. So the number of operations per operations, we are dividing the number of lines in WSDL, and we are getting what? We are getting there's one version 1, version 2, version 3. So what we are getting, so for this there's n version we had studied. So thereafter we'll see a parameter per operation. So for the version 1, version 2, again version 3, what does this is? Number of parameters, this number of parameters per per version of WSTL. So this is common in both the things, and divided by number of operations in that version, in that particular version. Similarly, for the message passing, number of messages in per WSDL, same thing, divided by number of operations in that version. So this will create again for version 1, version I, for version N. This is how this is for version I, because this is I, and similarly for this is also for I, version I. So you have, so again, what you are doing, number of operations line of code. In the code lines per operation, this is the fourth matrix, WSCLO. This is for version 1, version ith you calculate, version nth you calculate this formula. So for each of the version you calculate this formula, and all the four matrix. There are four matrix. This is third one, this is fourth one. So keep on creating these four matrix. Thereafter, what you can do summarization of this evolution mining such that this version 1 is there, this version 1 is there, version 1, version 2 is there, and version n up to n is there. So what you can do, you can create these four things for all the version. So four things are being created for all the version. Thereafter you can do this service evolution matrix like this for version 1, for each version over there. For each version you can have different type of the information, like this for number of lines, number of parameter per operation, number of message per operation, and then you have number of WSDL lines. So all these things are there. Then this, like this is the thing that we were discussing. So number of, and this is for a particular version 1, so version 1, and then you create the four time series. with this graphs. So the four time series are being created according to this. Then this is the service evolution analytics. So how we are going to combine this change mining and evolution mining information are being combined. What is this for change mining? It is for only for two versions. Okay, and this is for n versions. So this is for n versions. This is the basic difference between these two things. So the classifier is being used to do this, and here matrix is being used to do this. So there's a tool which has been created, AWSCM, for this. It contains change mining as well as evolution mining to do study over evolving distributed system. Then there's operation, the subset of operations which been generated. So this subset of operation is being used to create subset WSDL. Then service evolution information is being uh, created for time series. So for a time series, you get the trend like this for four different uh, matrix. These are version 1, version 2, version n, and this is values of these matrix. So this is how we are going to study. Then how the tool has been developed, this AWSCM. So AWSCM has been developed such that at time T1, the development starts for that tool, and the development process will keep on happening till time T2. So this testing time will start at T1 plus T2 time over here. Testing will start for that tool and it will end at T3. So this the both the phases will end at T1 plus T2 time. This is complete development and testing phase for that tool development, and the process that you are doing for the change mining as well as for evolution mining. So this is the way you can do. So versions of cloud services are being developed for the WSDL and web service code that are being used for development data from version 1 to up to some ith version, or you can say jth version, till that you have used, and thereafter from here onwards you will use from j plus 1 to the up to the n version. So this is being used for test, and this is being used for development. So this is the data, you can say, for web service data is there. So this is how you can define data for doing the testing and the analysis. Thereafter, what are the output, and so the output are WSDL, subset WSDL, which is a type of interface slice, that we had discussed in previous class. So there's two way for checking the correctness of subset WSDL. One is software acceptance. So if your subset WSDL which has been created is being accepted by IDE, that is NetBeans and Eclipse accept that IDE, then you can have uh, something being accepted as a framework. Thereafter, testing frameworks are like SOAP UI and JMeters are the two testing framework that actually accepts your subset WSL. Then, if this subset WSL is being accepted, then you can say that your WSDL subset WSDL are been working fine. Then there's human acceptance. If there's an engineer who can determine whether the tool has generated satisfactory output for the uh, for your subset WSDL or not. So this engineer can also determine that what's the output of your tool. Thereafter, this experimentation that we did is like this. So in the experimentation, we selected two self-made uh, web services, that is SaaS and book service. Then there's two real world web services that we had selected: AWS CM, AWS Amazon Web Service, as well as Eucalyptus. And this change classification that we had selected uh, for this WSDL slice construction. So this change classification we did for this WSDL slice construction. Then we did the empirical reduction. So these are the experimentation that we did. Empirical reduction for the regression testing of that cost. Thereafter, some experimentation has been done to study how this service evolution matrix is working over a time. So these are the experimentation that we did. So there are now we will show that how WSTL slicing uh, is being constructed. So the SaaS and book service. In SaaS and book service, what does this do? So in SaaS is basically uh, searching as a service. So indexing is being done, searching is could be done, and that according to that search, reading of the file could be done. So in this searching as a service, there's version 2 came up. In this again, index is kept same. Searching is being modified, but and the edit operation and edit file operations are being inserted according to green added, red modified, deleted, blue modified. So these are the example of changes that we retrieved while constructing that WSDL slice. Then in the book service, there are one, two, and three operations are being modified because there's one, two, three, four operations are being modified. So according to the modification, maybe there's change in one, there's change in two, there's so based upon this change one and two, this whole thing is being changed. All the four operations are being changed and affected. So this is how we can do the WSDL slice construction. So in this example, DWSDL is being created. DWSDL is being created and unit WSDL is being created for SaaS, for book service, for Eucalyptus code is available, but for Amazon Web Service the code is not available. So this unit WSDL is been not been created. For rest of the things, every DWSDL could be created, unit WSDL could be created. So first two are the self-made examples. For self-made changes are there in the subset WSDL creation, and the rest two are available on GitHub. Thereafter, there are three type of classification that are being possible. What are the three type of classification? Insertion, deletion, and modification. How they could be retrieved? They could be retrieved like this. So this is inserted. This operation modify node is being inserted. Migrate instance is being inserted. How they are being inserted? From February 2013 to the August 2013. There's Eucalyptus Cluster Controller WSDL. In this Eucalyptus Cluster Controller WSDL from this February 2013 to August 2013, there's some insertion had been occurred. I means new operations are being inserted, modified node and migrate instance has been occurred. Thereafter, some schema change been taking place, like some schema changes like complex data type, complex type CC instance has been modified, virtual boot is being modified. So you can do the complex data type means input output are being modified. So you can check out what are being modified. Then from May 2015 to December 2016, this same WSDL is having undergone this describe public address has been deleted. This operation has been deleted, and attached network interface operation is been inserted. So this is how you can find out. And this complex data type, complex. So this detach is been modified, detach volume response time. Accordingly, net config type is been modified. In the eucalyptus CC, this is example for eucalyptus CC. Now we are going to discuss about Amazon eucalyptus, that Amazon Elastic Cloud. So from February 2013 to August 2013, these operations are being inserted. Describe, re- reserved instance modification. Then these operations are being inserted from August 2013 to October 2013. So these are all operations that are being inserted. So this is how you can study these type of changes at complex types, means input output of data structure. Then what are the inserted operations and what are the deleted operations. Then these are the experimentation for the doing the reduced regression testing for the SAS self-made. So out of two, only five operations are being selected. Five operations are being added. So the two test cases are selected, and this resulted into 50% of test case reduction and 75% of test case reduction when we did the web service code analysis. And when we did for book service, the code analysis, web service code analysis, we got 60% reduction. How? So because three operation out of four operation are being modified or changed, so only two test cases are being selected out of five total test cases. So this given us 60% reduction. When Amazon Web Service, similarly, three operations are being selected out of 23. So we had created difference WHL only with three operations out of 23. And we got 86.95 reduction. Similarly, for Eucalyptus, we can say that we created difference WSDL and we got uh, uh, information of 92% effort reduction in test case generation and test case testing. Similarly, for when we did for the code level changes analysis, 88% of analysis uh, been removed, means reduced. The effort reduction has been done. So then the service evolution matrix part, that this says that there's two uh, cloud services are there. We studied, that is Eucalyptus Cluster Controller and Amazon Web Service Elastic Compute Cloud EC2. So there's two cloud services or large scale distributed system that we had studied, and their source code, how their source code are being changed. So this is the time series that where we are doing the analysis. From June 2006 to the June 2006 to 2016, we are doing the analysis. So just 2016. So these are the number of versions. So what is the version number? Version 1.0, version 4.3.1, till that we had studied. The number of commits to develop this version, 2000 plus, 500 plus, 4000 plus for Eucalyptus cluster controller. But we are interested mostly on number of lines, in the uh, this version, number of parameters in this version, then similarly number of code of lines in the code level, and number of operation. Based upon these information, we try to find out and calculated the matrix, four matrix. Similarly, we had gathered the data of Amazon EC2, Elastic Compute Cloud. So we are only interested in this number of lines of WSDL, parameters, number of operations. We are only interested in this. So this is not been available on this month. So this is how the we haven't collected for few months because of this. And this is how the four time series are being drawn with the help of that four service evolution matrix. So this is LOWSDL, POWSDL, MOWSDL, and WSCLO. So this development start happening for the two WSDL are green one is for eucalyptus and blue one is for the Amazon Web Service. Green one is for the eucalyptus and blue one is for the Amazon Web Service. So what we want to conclude and finish this presentation with this, that we did change mining as well as evolution mining over the evolving distributed system. Then how we did this? We first proposed service change classifier. We proposed service change classifier. We proposed service evolution matrix. Then we said that we did evolution analytics with the help of AWSM. So the two theories, theory one, theory two. So this is theory one, theory two. Service change classifier, service evolution matrix. Then for the this whole thing, service evolution analytics. Then this case study, what are the case study we did for the two web service? First SaaS, second book service, self-made. Then third one is for the Eucalyptus cluster controller and Amazon EC2, fourth one. And with this, we constructed WSDL slice. We reduce regression testing cost effort, and we plotted service evolution matrix time graph. With this subset, regression testing basically helps to do quality of service analysis and service level agreement analysis. So this paper research work has been published on IEEE transactions on engineering management. And there is a detailed link for this project available over here. You can see the two videos if you want, which will talk about AWSCM basic. Then these are the related publications like in transaction service computing, IEEE Cloud.com, and IEEE Masuka. And this is for concept. So in the next class, we'll discuss about quality of services and service level agreement, which would be helpful for monitoring and management of resources and provisioning purposes. So I hope that this would be fine. Okay, see
Yes,
you.
sir.
So any doubt or any question? Okay, so we'll meet in next class. Thanks. Bye.